We're going to start today the recitation, and it's going to be about two main things. It's the socket data structure and how the TCP protocol works. So the question is, why do we need to know that? Okay? And the obvious answer is it's going to help you debugging your code. Because if you don't understand exactly how the TCP works, it's going to be really hard to guess or to figure out what's going on. Okay, as we will see later, you are at the level of the application, so all you know is close, find, select, accept, but you don't know what the TCP actually does. So that's what we're going to do today. So we first start with the outline. We will just explain what the data structure is for the TCP socket, not for UDP, and the connection establishment from the client side, and from the server side. Okay, and then we will see how the TCP close and establish connection. Okay? So the main thing that you can see in here is the data structure. And as you can see, we are at the level of the TCP implementation. Okay? And the application level, all we do, we just say socket, like the one in here, and we pass the proper parameters, and we get back the descriptor. So once we have the descriptor, we can do whatever we want at the application level. Okay? But we need to know at the TCP level what's going on. So the first thing that you saw in the top, that you can see in the top, is the descriptor, the variables that you return when you call the socket. And you can have multiple descriptors pointing to the same structure, TCP structure. Okay? So the first field in the top, it's like receiving and sending queues. So if a TCP wants to send data received from the application level, it has to be in the send. If you want to receive from whatever the layer is, then it has to be in the receive. Okay? The other part, which is really, really important, is the close, which is mean here, the state. Okay? So the state field in here can tell you about whether the TCP in the closed state, established state, connecting state, or whatever the case is. Okay? So more than descriptor, you need to understand that. That can refer to this one. And here, these are the very important information, local and remote. Okay? We have a local information, which is the IP address and the port number, and we have the remote. And the remote in here is, it means that whoever we need to connect with. Okay? So these are very important information, as we will see in the next slides. So let's first take the client-side example. So when the client creates a socket, that's what we have. We have the TCP will create a structure, and it says the state is closed. So no communication. Okay, all we have is a descriptor pointing to a memory for a structure. That the only value we have right now is the close, which is the state value. Okay? Once we say connect from the client side, we are assigning the remote port and the remote IP address, those that we need, or the server or whoever we need to connect with. But here, as you can see, in the client side, we never care about the local port and the IP port. Okay, so who assigns them? Of course, the operating system, without you knowing about it. Why is that? Because we need to communicate. How can I call you if I don't have your phone number? How the operating system can call the other side. Unless we have this information, we cannot do the communication, or we cannot do the networking. Okay, so these two pieces assigned by the operating system. So we fill in the local address and the send connection request to the server. Okay? Once that's done, the client side do the following, which is to the TCP opens. Okay? Three-way handshake. The handshake means what? The client says, send a request. I need to establish a connection. if the server is in a stage to establish it, they will send back an acknowledgement. Once the client receives the acknowledgement, as we will see, it will create the connection. Okay? And the state now is what? Established. So we have an established connection. Okay? And as you can see, once you do this, another acknowledgement from the client sends back to the server. It says, now I have a connection, it's established. Okay, so be prepared. Based on receiving, as we will see later, the acknowledgement from the client side, the server will do some certain steps. Okay, so now we have the handshake is complete. We have an established connection. From where? From the client side. You always think in this way. Okay, what happened in the client side and what happened in the server side, and never mix them together. Okay? So now we can look at the big picture. At the application level, you call a connect. So connect actually does what? It block. While in the connection state, the client is busy. It cannot receive anything. You cannot hear to two people talking to you at the same time. So I'm just busy with establishing that connection. Okay? So we fill in the closed state is still closed. We fill in the local address. We send the request. And now the state is in connecting, but not established yet. So if you need to communicate with this connection, there is no way. So for a connection to be able to communicate, first we need to have a connection. So now we have a connection in the client side. Okay? All right? We have a socket, sorry, in the client side. And we still know nothing about the server side. Okay? So the connection in here, it's not yet complete. But when I say established, is the connection here is the socket at the client side. Because once we have this connection established from both sides, it can stay forever. Okay? So once that's happened and the acknowledgement received from the server side, now we have an established state. And remember, if there is no acknowledgement received, the client will time up for a certain time and give up. Try again. Okay? So that's exactly what the TCP does. And that takes like an order of minutes. It depends on the operating system settings. Okay? You have any question? Okay. So now let's look at the server side. So we only have a socket at this side. Once we have the socket at the other side, and they know each other, then we have a connection. Okay? So on the server side, it's the same. When we use the socket function or the system call socket, we are creating a structure at the TCP level. Okay? Actually, we are not creating. The operating system does that for us. Okay? And then once we use the bind, all we do right here, the state still closed, we just assign what? Local port. Why not local IP? Because the server will gonna be listen, right, in this socket. So all it does in here, it's local port because we are using the N address. Remember the system call that we have between the parentheses? The N address any. Remember this? N address any. So when you have this one, when you have this function or the system call in there, it says whatever the local IP address is. Sometimes you have multiple IP address in one host. So it will be listening, and like if you have 5 IPs, it will listen at 5 IPs. And if the request comes from any one of them, it will just map it to the right number. Okay? And right now, the remote port address and the remote IP is unknown. So all we do right now in the bind, set the local address and the port. Are we ready to accept a connection right now? If no, why? Exactly. So this is the state still closed. You can look just at the state, still closed. So I'm not ready yet. Okay? So the next thing that when we do the listen in there, the state of the sockets change to a listening. Okay? So in this case, as you can see, the only changing part is the state. Okay, so the state now is in the listening state, waiting for a request. Okay, comes from a client or whoever, or another server maybe. Okay? So any client connection request comes to the server before the listen, rejected right away. Okay? So there is no communication at all. So now if you look at it in the big picture, what you do in here, you have the call bind. Okay? And then the call bind, look at the states in here, closed and closed. There is no communication. And that's good for you. I mean, if you are trying to do debugging, then that's going to help you because you know. You are at this level in your program, or you're at the statement level in your program where you have the bind. Once you have it in there, set the state to the listening, and now we have a listening socket. But yet, we don't have a connection. Okay? When the connection request actually arrives from the client side, that's what we have, right? We established in the server side a connection that listens, right? And waiting for a request. If that request comes from the client, okay, so A, B, C, D, and P are the IP address and the port number of whom? The client. Okay? So if we have this information, the server actually does the following. Okay? It creates a new connection. Okay? And set the address and continue the handshake. Look at this now. The state is listening while connection in here is still listening. Why? Because we have accept, and accept is like connect, blocking. It blocks. It says, I can't hear you. Let me finish first. Okay? So once we have that, we have a new socket that's in the state of what? Connecting. Okay? And the socket actually is now added to a list that's actually done by the operating system. To a list is not a quiet list. Now we have almost a connection. We will see. Okay? So now we have that. At this point, we know that this is a new socket, and it has one thing in here. Remote is P, and that's sent by the client. Okay? Remote IP address is ABCD, so that's sent by the client as well. So now we almost can recognize a connection. We know that this is A, B, C, D, and the IB is P. Okay, and this one knows that in here, as we will see, we have W, X, Y, Z, and we have a Q as a port number. Okay, so at this part can refer to the other part by now assigning A, B, C, D, and P. To what? To the remote. Yep.
Can an incoming connection request be rejected by the server after when it is in the listening state too? Even when the server is in the listening state and a client sends an incoming connection request, can the request be rejected?
The request will be rejected because of the accept. We are in the accept state right now. We are not yet done. We're still in the connecting, as we will see later. In order to be done, you have to be in the established state. But right now, we are in the connecting.
So it will be assigned as soon as the connection request is sent to the server, right?
Exactly. And the handshake, yep.
Before the accept is followed out. Or is it necessary for the accept to be followed for the new socket to be allotted?
Yep.
After the accept is followed.
Exactly. Yep. Yep. You're right. Okay, so we will see now we are in the connecting state, and we have the whole required information that we need. Okay, the IP address is now WXYZ, and the local port is Q, and I know with whom I'm communicating, P and ABCD. Okay? So next now, just remember this. The IP address and the port number of the new created socket is the same as what? Listening socket. Remember this. Because we might have multiple sockets that they have the same IP address and the port number. And I will show you an example, then how can we do the mapping? If I'm having similar connection, because they're being created by the same socket. So how do I know, as an operating system, how can I map this? How can I demultiplex? We will see that in the following example, okay? So now, let's look at this example, okay? As you can see, the socket 0 and 1 are in what state? Listening. Are they the same? If you look at the port number, they are the same. Right? They have the same port number. They listen at the same port number. But they have two different IP addresses. For this guy, it's well known. I know my IP address. For the other one, number 0, the socket number 0, as you can see in here, it's a wild card. It means like I might listen at a different IP addresses. Okay? And then we have two established connection. Can you tell me socket number 2 created by which listening state? By which listening socket? Can you look at it? This one is in an established state. It means it's being created by either one of these. So who's responsible for that? 0. Why? That's right. It's 0. But why? Exactly. So if it's being created by this listening socket, it should have the same IP address, though they have the same port number. Okay? So the wildcard here can be what? Any IP address. Okay? So this is any IP address. So I know that's being created by this socket. Okay? So now just imagine that we have the following packet. Okay, we have this packet. Okay? So the source IP address and the port number are as given in there. The source means whoever sent the request. Okay? The destination here means to whom am I communicating? These are the port number and the IP address. So imagine now the operating system is, or the TCP, when I say the operating system, I mean the TCP. Okay, because TCP is a part of the operating system. Okay? So in here, how can we map this? Because now 0 and 1 have to figure this out. They receive this packet. Okay? And we know now the process. They have to establish a connection or establish a socket and release it. They said, okay, go away, we're done. Okay? So how can they map it? So the first thing, let's look at the IP. That's the rule. Let's look at the port number. Yep. Socket. That's a good question. It's any IPs in your host. It doesn't matter. As long as, let's say we have 3 IPs. 1, 2, 3 IPs. Okay? So if it's 1, I can handle it. If it's 2, I can handle it. If it's 3, I can handle it. Exactly. All right? So if we look at the port number, both of them listen at the same port number. Okay? Then that's not something that's going to help, right? Let's go to the next level. Okay? Look at the IP address. Okay? You might say, this IP address matches this, it's fine. No. The white card can be any IP address. Then this one also can be the key. So that's not, if you think that's the difference, then you are wrong. Okay, it's not by the IP address. The third rule is what? Look at the wild cards. which one of these sockets has less wildcards? Which one of them? Socket number 1, right? Then map it to it. It must be there. Okay? So never assume that, okay, this is the number, that's the number, they're similar. No. This one is also exists in this domain. Okay? So that's not something that distinguishes the packet. So now we have to look. The operating system goes to the third rule, which one has a fewer. So this one has a fewer, then that's the one, map it. Okay? So this is just an example. If you have the time, sit down and come up with different cases. So that's going to help you a little bit understand what the TCP actually does. And believe me, at the application level, what you do exactly is just you say call, connect, or bind, or whatever the command is, or the function is. But that's not enough. Okay? So I just postponed it in here. Just jump into the example right away. Here I said we are in the connecting, but it doesn't mean that we are having a connection right now. Right? So if you can see here, just after the example, when the third message comes from the client, the new socket is what? Is established. Now you have a socket in here. Okay? So what does it mean, the third? First, we received a request. Then the server sent the acknowledgement. Then now we're having what? A connection, a socket. Okay? Once we have the socket, it's a 3-handshake message. So the 3 means 3 messages. Now once it receives the acknowledgement, it says, I'm established. Once that message is received by the server, it says, okay, now I'm changing the state. It's no longer connecting. It's what? Established. Okay? So there is key things that we need to know in here. The original server or the original server socket will never change. It will be listening in the same port, and in the wildcard IB, all of there is multiple IBs. Thank you. Okay? So as I told you, this is going to be forever, as long as you have not dislocated. So it creates a new socket. Once it's done, established, getting back, because of the accept, right? The accept will block. Now we are connecting. The connection is established. Go away. I'm getting back to the listening. Okay? Your question.
So basically the steps is listen, server listen, client send request, server receive request and block, server send acknowledgement, it's still blocked, and client sends the establishment connection message, and then the connection is established
At the server side.
at the server side.
Absolutely right. So the connection here, or the socket here, is created when we receive what? Just remember the 3 handshake HS, okay? Handshake message. First, the client sent a request. It says, this port number and IP address, and this is my port number and my IP address, send it to the server. It says, I need a request. Okay? That's number 1. Number 2, the server here will send what? An acknowledgement, ACK. Once this ACK is received by the client, we have a socket, and the connection is established. Okay? Once that's done, the client will send another acknowledgement. It says, my connection from my side is established. Once that's received in there, the ACK, let's say this is 1, this is 2, the server now changed the state from connecting to what? To established. Once that's done, it says, accept is done the job, collect some important information, as I will show, okay, collect some important information, and we'll pass it somewhere to the accept. So the accept establishes the connection, and we are back now at the TCP level in the listening. We are waiting for another request. Okay? So if we look at this, That's the whole picture. At the application level, we just call the accept, block, until what? A new connection is established. So let's look at it again if you are confused. So this is the listening, incoming connection from where? Client, another server, whoever. That has these pieces of information, ABCD and the port number. Once that's done, create a new socket for this new request. Is it possible? If it is not, then it will reject it for some reason. Okay? We create a new socket, we set the address, we continue the handshake. So the handshake, the reason why we are saying connecting, because we just sent what? A request. Waiting for what? An acknowledgement. Okay? Once we receive the acknowledgement, it means the handshake is complete for the client side. Okay? Now we have an established connection at the server side. Okay? So now we have two sockets. They know each other through their IP and port number. Then now we have what? A connection. How can we access this connection? The descriptor. As long as you have the descriptor, you have that connection. It's going to be there forever, unless you destroy it. You can pass it to whatever function. You can pass it to whatever application. They can communicate through that channel. A channel is being created for you at both sides. Okay? So this is exactly what happens when we create a connection, and that's the process, at the client side and the server side. Now we need to know how to close this connection. Okay? So the basic idea here, I said when one application calls close before the other end closes. And then I said, what? I have a reason for this what? Because both sides, they can close the connection at the same time. But in this example, I'm just assuming one of them does it before the other. Okay? So one of them just did, send the request to close before the other one does. But they might happen at the same time. If you want to know that, go back to the operating system class. And that's an operating system concept, which is the processes management. Okay? Because there will be no collision. Okay? And the operating system is well known for doing these tasks. Okay? So once we have that, before we do the connection, remember one thing. Whoever initiates closing the connection will send all the data we have in the send queue. And it says, I have no longer anything that I need to send to you. Okay? And then the second thing, handshake message is sent. And I said between parentheses there, I said end of transmission. It's like a marker. Just send a handshake. I said, okay, all I have has been sent. Okay? You don't need to expect anything from my side. Okay? Once that's done, the descriptor is delocated. Okay? And then the state is set to closing. It's not yet closed. Okay? Why is that? Because the other side has to inform the requested side that they want to close the connection. And that's going to be one of the challenges when you try to manage closing your application from the server side or from the client side. You will always have a problem unless you understand this process. Something wrong will happen. A question? What can we what? Oh, yeah, we will see. That's the whole process. That's a good question. Why not just throw it away? By the way, we said what here, number 3? Descriptor is what? This deallocated. Doesn't mean the structure, the socket itself is being delocated? No, not yet. And why is that, as we will see in the next slides? We just said this is a pointer. Descriptor is what? A pointer. Points at a memory. And that place, we call it TCP socket. That's it. When you dislocated this, you have no way to access the memory, but for security purposes, you can go there, do some sniffing, and get some information from the memory. Okay? So when the acknowledgement, I said the request, I said I want to close the line, or I want to close the connection. when I receive the acknowledgement, I am in the have closed. Now we move from the closing to a have closed. Why? Because from my own side, I'm have closed, because the connection has two sides. The other half is not yet start the process. But from this side, we say, no, I'm have closed. I have nothing else to send to you, I'm sure. Okay? So this remains until the other handshake message is received from the other side, as we will see. So when the other end handshake message is arrived, I said, I need to close the connection, and I receive the request, okay? And now in the have closed state, and then when the other end's close, handshake message is arrived, the acknowledgement sent, and the state changed to time wait. So it's closing, have closed, time wait. Why is that? Why time wait state? Can you think about it? Why do I need to wait? Just destroy the struct, the socket. Why do I have to wait? Yep.
You need to make sure you get that acknowledgement that the other side received the close. Make sure you close that.
That's why it's in the time wait. It receives that message. That's the problem. I received it, but I'm still in the time wait. Waiting for what? Uh-huh. Uh-huh. A little bit close. Because of the delay in the network, there might be packets in the network, still in the network. And if you destroy this right away, the port number of this socket will be assigned in, if someone create a new socket, to that new socket. And if that delayed packet came in, it will go to the new created socket by the old port number. And just imagine if this information is money or something very, very, very sensitive. Then the other guy just happens to listen at the port number that's been used by the other socket, so that's why we need to time wait. That's the reason why. That's the first reason why. Message being delayed in the network. Okay? And how long that's going to take? They calculate the time takes a packet to be in the network, and then they double the time, just to make sure. If it takes a packet like a minute, they say, wait for 2 minutes. If nothing happened, destroy the struct. Okay? And the time usually goes from 30 seconds to 2 minutes, okay? So now, what will happen to the endpoint that does not close first? So now what happens? We know what happens exactly to the one that sent the request of closing the line or the connection, right? So what happened at the other side? Now we know in here, it's in the time wait for some time and it will disappear. But what will happen in there? And you might think about the time. Do they happen at the same time or simultaneously or in a different time? That's for you to think about. Okay? So when the closing handshake message arrives, it says here, I send the request, receive the acknowledgement. It says, okay, having the other message, I said, I'm done. I'm in the time wait. Once that's received, we are thinking in the TCP level right now. Okay? So the TCP level at the server side, acknowledgement is sent immediately. The connection becomes in the close wait. I want to show you this one. So we have an established connection at the server side, okay? And the handshake is received from the one who initiated the closing. Then it says, I'm in the close wait. That's what the server says. Why it says I'm in the close wait? Now we have a different state, right? We have a closing, we have closed, we have time out. And then now in the server side, we have a close wait. Wait for what? Wait for the application level to call what? The close. Because at that level, your application knows nothing. Just the client, close the connection, send an information to the server side. It says, if it happens that you want to send anything, I don't have that connection. The server side said, okay, send back the acknowledgement. And if your application tries to send to that connection, if you don't handle it, you might have a collapse to your application. Because the server said, I know this connection is destroyed. Okay? So if you are lucky, the operating system will give some important information. Otherwise, your application will collapse. So you need to handle that as well, if it's required. Okay? So the server side here, when the application called the close, in here, the descriptor is dislocated. The handshake message is initiated. Why? Because I also want to tell the client that I'm done. Okay? I'm done. If you want to like recreate the process all over again, I'm done. Okay? And then it says delocate the socket structure. Now the structure is gone. You didn't have the structure at all. Okay? So that's the way we close the, the TCP IP closes the connection. Okay? And we know it now in both sides, in that side and in the server side. Okay? So this is the whole process. All right, so here we call the close. We initiate closing the connection from one side. It was established connection. Then now we are in a closing state. And then once the close handshake is received from the other part, in our example or in our project, it happens to be what? A server. Okay? And then we are in the have closed. And we know why in the have closed. We are just like waiting for the third message to be received from the other side. Once it is, then time out for a certain time, and the connection is destroyed. Okay? So this is the way the whole thing actually takes place. All right? So if you have any question, let me know. Yep.
So what happens if, say, one of the sides has a power cut?
In what state? That's a good question. Establish a state. It's not yet done, right? Yeah, that's when you need to manage your code. But in our application, it's very simple. You don't need to think a lot. I'm not going to create test cases to go for that. Okay? You can, yeah, that's one way to do it. I mean, it's programming. I always call it art. You know, there is no one certain way. It's an art. It depends on how you understand the problem and how can you map it, okay, to the solution domain. And then you can think about a lot of stuff. And in C, if you are using C and C++, these are the languages that have been used to create the Linux and Windows as well. So you have a lot of interfaces to figure out solution to these problems. But that's a good question. There are a lot of questions, actually. What happens if I just send the request to the server, okay, and the server sends the acknowledgement, and once I receive the acknowledgement from this endpoint, I just want to send the handshake number 3, and the server was down. So what will happen in there? So these kind of like scenarios, you can think about them. And you can figure out the solution for them. But not for your project. For your project, make things easier. Okay? Just make it simple. Solve the problem, learn the basics, because the next project is going to be a challenge project. And you cannot do it by yourself. That's something I can tell you from now. You have to find a partner in order to do it. It's not like something impossible. I did it by my own when I took this class. But it was a crazy idea. Don't do it. Please don't do it, okay? It takes most of your time. Okay, but the thing that you're going to learn what the industry actually looks like. In the industry, you are not responsible for solving all the problems. You just have your part, get it done, communicate with your friends. How can we put these two pieces of code together to make things work? That's actually the reality. So do it. Find your partner from now. Okay? This is it for today, guys. Thank you.